Okay, for those of you working at home, I just want to go over some key points for this worksheet to help you to fill it in. Avogadro's hypothesis, which is actually Avogadro's law now, says that if you've got two gases in two identical containers, okay, so the volume of each container is the same, and they have the same temperature, and they have the same pressure, we can conclude that the amount of particles in each container is the same. And if we've got containers with equal numbers of particles, it allows us to compare those different gases when they get involved in chemical reactions. And it'll tell us something about those particles. So our first question is answered. The number of particles is equal. Then we're going to do some drawings, and in each of these boxes we are going to draw equal numbers of particles. You can do 3, 4, or 5 particles in each box. To be quick, I'm just going to draw 3, and if you choose 3, just be consistent. So here we've got hydrogen. We can represent hydrogen with simple circles. I've got 2 boxes of hydrogen, 2 volumes of hydrogen. I've got a volume of oxygen, and when they combine, they make water. And what we've got to do here is we've got to combine the hydrogen and the oxygen to make water. Water, we know, is H2O, and considering that it's H2O, we're going to have 2 hydrogens bonded with every oxygen, and that means we've used up all our hydrogen particles and used up all of our oxygen particles. Then we're going to do the same with hydrogen and chlorine. I'm going to be consistent with my colors here. I'm going to draw 3 hydrogen particles and 3 chlorine particles, and I'm going to combine them to make a product. That product is called hydrogen chloride, but I also don't want anything left over. So I'm going to have my 3 chlorines bonding with hydrogens. So there we go. That's what you do in the next one. Now we've got one that's a little bit more complex. We've got nitrogen and hydrogen combining. We've got 1 volume of nitrogen and 3 volumes of hydrogen. So nitrogen I'm going to make brown. Hydrogen I'm going to keep it pink. Since I've got 3 times as much hydrogen as nitrogen, when I combine them to make ammonia, you can logically see that if I'm going to have nothing left over, I'm going to have to stick 3 hydrogens onto each nitrogen. So part 1 of this worksheet is very logical. Part 2, we're going to start making some changes, because when scientists did these reactions, they found out that, for instance, with the hydrogen and chlorine reaction, that you actually made 2 volumes of hydrogen chloride. So if we do this and we take our chlorines, 2 volumes of hydrogen chloride were made. But that doesn't seem possible because, I need to go back here. These guys I didn't want here. If I'm making 2 volumes of hydrogen chloride, I've got too much stuff, too many particles on the right and too few particles on the left. We can't just create particles out of nothing. So scientists concluded that hydrogen and chlorine must be diatomic. That means that the particles aren't single atoms, they are molecules. They come in 2s. And so this is how the reaction actually happened. And we can represent it with a chemical equation. We can say H2 plus Cl2 gives us HCl. But we can also write this as a balanced equation and put a 2 in front of HCl, because I'm making 2 volumes of hydrogen chloride. But the key takeaway here is that hydrogen and chlorine are diatomic. Hydrogen we write as H2, and chlorine we write as Cl2. We're going to apply that same principle to the reaction between hydrogen and oxygen to make water vapor. So hydrogen comes in twos. I'm just going to do 3 molecules of hydrogen. Oxygen, can't remember what color I used for oxygen, but I'm just going to use, let's make it orange. Actually, I didn't do oxygen yet. Oxygen is also diatomic. And when hydrogen and oxygen combine, when we make our water vapor, we are going to make 3 molecules, and each molecule, you know that hydrogen is H2O, each molecule is going to have 2 hydrogens on it. Now, if you're doing this yourself, you may want to draw 4 or 5 particles in each container. It's really up to you. So the balanced equation for this is H2, and it's actually 2H2, because there's 2 volumes of hydrogen, plus O2 gives us 2 H2O. So 2 volumes of hydrogen and 1 volume of oxygen. We don't use a coefficient when we've got 1. It gives me 2 volumes of water vapor. And the last one, I want you to try this on your own based on what I just showed you. We've got nitric oxide, we've got oxygen. They're going to combine to make this reddish gas, and you don't want to have any oxygens left over. You don't want any nitrogens left over. And we can figure out here, oxygens are the clear ones. On the left-hand side, we've got oxygens. The oxygens are the clear ones. So you want none left over. You don't want to have more on the one side than the other. So combine the oxygen and the nitric oxide in some way to make a reddish gas, and see if you can figure out what those molecules look like. And I'll start the balanced equation off for you. It's going to be NO, because I've got 1 nitrogen and 1 oxygen, plus O2, and actually it's 2NO, and that's going to give me 2 volumes of this reddish gas. See if you can figure out what this reddish gas is by drawing the particles. I hope that helps. Let me know if you've got any questions.